Hello and welcome to the tutorial in GeoStudio 2020. In this tutorial, I'm going to guide you how to do the analysis for a slope. We're going to do the slope stability. And the first time when we open this one, you need to choose the available license for you. If you use a university computer, just use the best available license. And after that, you have to select the template. By default, GeoStudio use the Imperial where the dimension is in inches or miles. However, I hope you can use the SI system. So you have to select the metric and you also can choose the workspace as well. But for this simple, we just use metric. About the dimensions of the study, you can do from 1D to 3D, but in this simple tutorial, we are going to study the Swedish method, so therefore we are going to do the 2D. Now, the analysis, which is a parent of all other analysis, it may be logical if you do the slope analysis, so you choose slope W first. However, you want to have the water table calculated from SIP-W, so you will import the water table from SIP-W. So therefore, I think it may be better if select the SIP-W first. And now you can see here, you have the SIP-W analysis, and as I told you before, we add the slope W as a child of this parental analysis. So therefore, you can import the water table from SIP-W to the slope stability. Now, in the analysis of the SIP-W, you have to choose a steady state, not transient, because we are going to do the short-term analysis. There are a lot of options over here for you to study the transportation of different components of groundwater, like vapor transfer, air transfer, solute transfer, and others. In this tutorial, we are going to study a very simple example, so therefore I don't take on any of them. About the property of water, I'm going to use the default value. And about the time, because we use steady state, so therefore I'm going to leave it at 0 day. Now, in the next part, the slope stability, we are going to do with the half-size side functions. As I explained you in the lectures, the half-size is my favorite one because of the reality it has. However, based on your material and your geometry, you can choose other function for your slope. About the PWP, PWP stands for pore water pressure, and you import it from the parent analysis. That means the CW. And I don't choose any others. Now, about the parameter of slip surface, you have the first option is the direction of movement, so it can be left to right or right to left, or you can use a passive mode. You know, if you choose the wrong directions of movement, so you could not find the right factor of safety because the soil block cannot slide upwards the slope. In the second one, about the method of analysis, you have five different options here, and the most two popular is the first two, that's the Entry&Exit and the Grid&Radius. We are going to study in this tutorial. And I don't do any tension crack options. If you have some tension crack option, you just put it here as an angle and the line. About the distribution, in this one, the factor of safety distribution calculation could be a constant, not a probabilistic. And in the advanced, you have several other, like the number of slices you want to have. In here, they have about 30 slices. It's just good enough information. Because if you know, if you go further, thinner, it may be not accurate because of the heterogeneity of the soil. Soil is not the same everywhere. So the slide must be big enough so you can consider soil as a uniform material. About the minimum slip surface depth, so it's about 0.1 at at the moment. That means the sliding block must have the thickness at least 0.1. The sliding surface must go into the slope at least 0.1 meter. And I think maybe that's enough, so I close this one. I forgot to introduce you again about the list of different methods about analysis type. My favorite is Morgan's price, and it's also the default by slope W. However, you also can select other method that is also available. And I also introduce you the basic difference between those methods in my lectures. The most important part is inter-slide force. Now, just close this. And we start to draw the space we have. Okay, so in the first step of analysis, you need to draw the working space first. So I click on this one to sketch the axis of the space I want to work with. So here's what I have. The length is about 60 meters and the height is about 19 meters. You can change this one if you want to, but in this tutorial I'm going to draw an approximate geometry, so therefore it's okay for me. Now, to start drawing the geometry, I have to click on the draw region. And I start to draw the foundation first. Yep. So when you finish drawing one region, the region turn to gray, and therefore you can know that it has been drawn. If it still has some dash line inside this region, so that means it has not been finished yet. And the reason why it is gray because the material has not been assigned yet, and you need to assign it later. Just finish the geometry first. So in this example, I draw just a rough approximate geometry. It's not exactly right, and you can choose something better by yourself. For example, the place before the dam must be larger, about 2 times of the thickness of the foundations. So you can ensure that the flow inside here has no influence on the dam stability. Now you can see I just draw the foundation and the dam body. I need to draw the drainage as well. In general, if you want to do it accurately, you can use draw point and then connect the points. For example, if I draw a point here, I can enter exactly the positions of the point. For example, I change this one to 20.5. So you can see now it's moved to 20.5. But in this simple tutorial, I don't think I need this one. Now just keep drawing the drainage. And I think I may need some intermediate point for my water level. Okay, so that is my geometry. In the next step, I'm going to define the material property for the dam. So I just click on define and click on material. In these situations, I have 3 materials, so I just use 3 different ones. The first one may be the foundation is maybe made of sand, and I use a saturated only to avoid the complicated you need to do with the hydraulic conductivity function later. In this one, it's just a simple tutorial, just help you to break the ice only. So the saturation conductivity of sand, I give it 10 minus 5. And the saturation volume content 0, compressivity 0. And the Kx, Ky on Kx, the ratio of the hydraulic conductivity in the horizontal and vertical direction is 1. That means Kx equal to Ky. Now I add one more. Now for the dam bodies, I use something that have lower permeability. So you can see that will be a strong flow of water underneath the dam later. So here I'm going to use something like silty clay. Silty sand, sorry. And because of silty sand, I move it to something darker to hint that it has a lower permeability. And the saturated conductivity is 1 minus 6, for example, like that, or 7. So it's 100 times lower than the sand. And the last one I add for my drainage over here. So it should be gravel. And gravel, I set it lighter, maybe this one, to hint that it has higher permeability. And I get is 1 minus 4, for example, or 3. So you can see that we will have a very, very different permeability of the material in this one. In general, we don't have that simple geometry. We have some inverse filter layer over here to prevent the erosions and to smoothen the transition from a low permeability zone to a high permeability zone. Now we just try to assign the material. So I assign gravel to this one, just click on it. And then I change to sand, click on the foundation. And I change to silty sand and click on the dam body. So now you can see that all of the material has been assigned. If you use more than 3 material, you need to use the educational license. You cannot use the free license from the Slope W because it's a limited set by the company. However, as you use a university computer, you can have the educational license and therefore you can simulate as many sources as you want to. Now, the last thing is adding the boundary system. So I need to add up the hydraulic boundary conditions. And I have the water table start from 28, it comes from the reservoir at the point 16 and get out the dam at point 17. So the first one I need to define boundary conditions. I delete all of them because I don't need them. I just add my new one. So my new boundary condition for upstream will be constant by head. And the water total head is 28 meter. As it is a coordinate of the 16. Now I add one more. And to define this one as the lower one, so I change the color to blue to differentiate. So it will be downstream now. And for the downstream, the condition also the water total head. And the constant is about 7 meter. Close. And now I just draw the boundary condition. So for upstream, I click on the line I want to apply it. So, yep. And now I align the downstream to what I need. And that is the end of the configuration for ShiftW analysis. Now in the next step, we are going to set up for the slope analysis. And as we did in the ShiftW analysis, we have to define the material first. Because different analysis will use different properties, so you need to define it again with the properties the analysis needs. So now, if I go to send and I use a more column, it's the simplest one. You can use different one for different type of analysis and different material. So the unique width for sand, I set it at 18. The cohesions, I set it at 2, or maybe 0 is fine for me. And the phi, the frictional angle, I set it about 30. For the CT sand, I will have a smaller unit weight, so I set it at about 16. The cohesion should be higher because it has some silt in that, so therefore I set it 20. And the frictional angle, the internal frictional angle, I set it about 28, maybe too high, 26. Now the last one is the gravel. I need to set the more column for that. The gravel is about 20 kilonewton per cubic meter. The cohesions. Cohesions of the big one like this is very, very different. It can be 0 and mostly 0 because the big particle, they have angular contact and therefore no cohesion between them. But it has some geometrical resistance, but I will keep it 0 as normal. And here I set it higher, maybe 34. Yep, and that is end. Now I have to assign the material to the region I have drawn. So on gravel, I click here. Sand, I click on the foundation. And CT sand, I click on this one. So this is a material. I don't need to import the water table because it could be automatically. Now I need to draw the entry and exit. So when you draw the entries and exits, you will try to define where the sliding block will start and where it will end. For example, in this tutorial, I try to draw it. I will try to draw it from around the point where the water gets into the dam. That's my entry. And my axis just below it, down on the way to here. And that's it. So here is a setup for my slope W. Now, after you have defined the geometry and boundary conditions, the only thing you need to do is to run the analysis. So just click on Start. And it will ask you to save it before you can run. So I just save it as a test. Something wrong with this. So I think I have done it wrong. Okay, so 28 is actually the x coordinate, not the y coordinate. So therefore you have that very big over here. So therefore you have the water fall down on this one and get into this one, and it's the not logical one. Let's go back to definition and change it. So here I need to define my hydraulic boundary condition again. So the upstream is not 28, it's just about 15. And the downstream it was 7. So that's why close. Run it again. So you can see now, here will be my water table. Now in the next step, I'm going to guide you how to use the grid method. And to do that, you need to go to definitions and define the project again. So in the slip surface, you use grid and radius. To draw a circle, you need two things. The first one is the center, and the second one is the radius. So the grid and radius method will also do that. So the first thing we need to draw the grid of the center. So for example here, I draw a grid of the center and I take the increment is 5 by 5 for example. So now it will draw a lot of circle. Each circle will take the one point at the intersections of this net as a center. And now the next one I need to draw the radius. In GeoSlope, you don't have the radius defined by the value, but you have the radius defined by the tangent line. So when you try to draw the slip surface and you draw the radius, you will be able to draw regions with a lot of the tangent line to the radius. So the computer will try to draw a circle with a center from the net, and it has the radius tangent. The circle is tangent to the set of lines you have just drawn over here. Now let's see, and now let's see the analysis. Yep, so you can see that here is the contour of the safety factor, where if you look at the circle, you will see that each of the circle will take one point in the net as the center, and it tangent to the set of lines you just draw for the radius. And you can find the point with the least factor of safety over here is about 2.34. So as you can see that the 2.34 is bigger than what we had before with the entry and exit method. There are two reasons for that. The first one is for this one, you have a coarse grid. So therefore, the point can be somewhere over here, over here, over here. You don't know. The second one is when you try to limit the tangent line, it may be not the right direction you need to. So you have to refine it. As in the entry and exit method, you have to refine the location of entry and exit. In the grid and radius method, you need to refine the location of the net and the increment of the net and the tangent line. And they all give you the answers, and the answers should match if you refine it well enough. Before I finish this tutorial, I just want to emphasize again that this is just a simple tutorial. There are a lot of mistakes in that one, so please do not copy it for your design. For example, the slope of the dam inside the reservoir must be milder than slope at the downstream side because it has the saturated part over here, so therefore it has uplift force, and therefore the soil block easier to slide down, and it doesn't have a strong drainage over here to support at the toe, so therefore the slope here must be milder than the one at the downstream side. The second thing may be interested to you that the side road that we often use to reduce the slope and use for the dam repair is actually inside the reservoir. It should be on the other side, on the downstream side, where it dry, and you can go over to observe, take a sample, investigate, drill hole at anything like that. Um, the road on the top of the dam is also not big enough, and there are also no protections for the dam from the wave, and there are no inverse filter layer over here to prevent the erosion, because the soil hydroconductivities they are very different, about 100 times different from here to here, and about 10,000 times different from here to here. So therefore, this is not a perfect example for you. It's just an example for you to break through the ice. Please do not copy it. It could be totally wrong. Um, you have to be creative to create your own artwork. I hope you enjoyed the tutorial and see you in next time.